Welcome! In this explainer, we're going to dive into something pretty cool, the secret guardian of our entire power grid. Yeah, I'm talking about a tiny component that protects these massive, multi-million-dollar transformers. Without it, well, the lights could go out. So what on earth could it be?
I mean, it seems totally impossible, right? How can this little box of, colorful crystals be the main line of defense for a machine that's the size of a truck? But believe it or not, it is. And the secret to how it all works, well, it comes down to a really surprising fact. These huge transformers, they actually breathe.
All right, so let's get into it. The breathing machine. Now, I know that sounds weird, but yeah, transformers have to breathe. And it's all driven by temperature, pressure, and the huge amount of oil sloshing around inside them.
Okay, so here's how that cycle actually works. When a transformer's really putting in the work, its insulating oil gets super hot. And what happens when things get hot? They expand. That expansion pushes air out of the transformer. Then, when things cool down, the oil contracts, and that creates a vacuum, sucking the outside air right back in. And that's it. That's the breath we're talking about. So this whole breathing thing, it's completely normal, totally necessary for the transformer to function. But here's the catch. Every single time it takes one of those breaths, it's potentially inhaling a silent killer. So what could be lurking in just a simple breath of fresh air that's so dangerous? The enemy? It's just moisture. Simple H2O. But when that water vapor gets inside the transformer's oil, it is absolutely catastrophic. It just wrecks the oil's dielectric strength. You can think of it like poking a bunch of holes in a raincoat. Suddenly, the oil can't do its job of insulating all those high-voltage parts. And what's worse, it starts to destroy the paper insulation wrapped around the windings. It is a total recipe for disaster.
Okay, so that brings us to our next part, the moisture-fighting guardian. To let the transformer breathe safely, without, poisoning itself with moisture, it needs a filter. And this is where our hero comes in. This is its first line of defense, the silica gel breather. And the solution is it's beautifully simple. Silica gel is what we call a desiccant. Basically, it's a material that is incredibly thirsty for water. You can picture it like a microscopic sponge. So as that moist air gets pulled in, the gel just snatches the water molecules right out of it and only lets clean, dry air get through to the transformer. Pretty clever, huh?
So this one little material is a seriously multi-talented guardian. I mean, it protects the oil, it shields the paper insulation from breaking down, it even helps prevent internal rust, and this is the best part, it has a built-in visual alarm system that tells you exactly when it's time for it to take a break.
Which brings us to a spectrum of safety. So how do you actually know if this little guardian is still doing its job? Well, engineers came up with a brilliant solution. They made a silica gel that changes color. It gives you a super clear visual signal of its condition.
So out in the field, you're going to see two main types. The traditional stuff is this deep blue color when it's dry, and then it turns pink as it soaks up moisture. But there's a newer, safer version that starts out as a vibrant orange and turns green once it's full or saturated. It's just a really simple, at-a-glance health check for the system.
So you might be asking, why the big change from blue to orange? Well, it all comes down to a single chemical ingredient. The blue indicator uses something called cobalt chloride. Now, it works great, but we now know it's a potential carcinogen. The orange gel, on the other hand, uses a totally cobalt-free indicator, which makes it a much, much safer and more eco-friendly choice for everyone involved.
And that really just sums it all up, doesn't it? The whole industry is shifting. The future of keeping an eye on these systems, safely and responsibly, is definitely moving away from that old blue to pink standard and really embracing this new orange to green transformation.
All right, time for the regeneration ritual. And honestly, this might be one of the coolest parts of this whole story. See, when the gel is totally saturated and it's changed color, you don't just throw it away. Nope, this little guardian can actually be reborn.
The signal for the maintenance crews is super simple and really clear. When about 2/3 of the gel inside the breather has changed color, that's it. It's not really effective at trapping any new moisture anymore. So that's the big sign that it's time to either replace it or, well, regenerate it.
And regeneration is basically just baking the moisture out. You heat the saturated gel in a special controlled oven, somewhere between 120 and 180 degrees Celsius, and that heat just forces all those trapped water molecules to get released. And just like that, The gel goes right back to its original deep blue or vibrant orange color, totally recharged and ready to get back to work. It's a really fantastic, sustainable process.
So the whole maintenance routine is really straightforward, but it is absolutely vital. First up, you do a simple visual check of the color. Easy enough. Second, you do a quick check of the oil cup that's at the bottom of the breather. That's just there to catch any dust before it can get to the gel. And finally, if it's time, you swap out the saturated gel with a fresh or regenerated batch. That's it. Just a few simple steps to protect a multi-million-dollar piece of equipment.
So, hey, the next time you're driving past a substation, take a closer look. See if you can spot that little breather box on the side of a transformer. It's just a perfect reminder that our modern world is built on countless, simple, elegant solutions, all working silently in the background. It really makes you wonder, doesn't it? What other invisible components are out there, quietly making our whole world work?